Hi, everyone. Welcome to our next video for week 5 on hypothesis testing. In this video, we're going to talk about the p-value method. This is a method that relies more heavily on technology, and you will need a calculator or computer to help you with this method. So the p-value method is actually a little bit shorter. It has 4 steps versus our 5-step traditional method. So first is exactly the same. We're going to state that null and alternative hypothesis and then identify the claim. Second, we're going to calculate something called the p-value. And the p-value is based on our sample data. And we'll talk more about that in a minute. But this is the place where you show your work by writing down the calculator function you use and the inputs that you put in the calculator. 3 is where we make our decision regarding the null hypothesis. And then 4 is where we write our conclusion. You'll notice that steps 1, 3, and 4 sound a whole lot like steps 1, 4, and 5 in the traditional method. So all the p-value method does is takes that critical value test value step and kind of squishes those 2 steps into one. And bypasses some of that extra calculation we're doing. So let's quickly go through this and we'll focus mostly on step 2, which is that new step. So for step 1, exactly the same as the traditional method, write the null and alternative hypotheses, make sure you label which claim is being tested. For step 2, we're going to calculate the p-value. And that p-value represents the probability that you will get results stated in the alternative hypothesis, assuming that the null hypothesis is true. So the p-value is the likelihood of getting a result that is, oh, I just had a brain fart. I'm sorry. Getting a result that agrees with the alternative, assuming that the null is true. And this information is based on our sample data. Based on our sample data, how likely is that to happen? If your p-value is smaller, that's a smaller probability. That means that outcome is less likely. So that's more evidence against the null hypothesis. What a small p-value is telling us is that if the null is true, it is very unlikely that we would see the information that we saw in our sample data. If we get a larger p-value, that outcome is more likely. What that's telling us is that our sample data is too close to that null hypothesis for us to really be confident that there is a significant difference there. So smaller p-values are better. We're more likely to reject the null. Larger p-values, we're less likely to reject the null. In both cases, we're comparing those p-values to the alternative hypothesis, or not the alternative hypothesis, sorry, the alpha value. So when we compare our p-value in step 2, we're comparing it to that alpha value, the level of significance. If the p-value is less than the level of significance, we have a very small p-value, we reject the null. If the p-value is greater than or equal to the level of significance, we do not reject the null. Ooh, Mr. Jolliffe had a slight brain fart there, sorry. I had those symbols reversed. If the p-value is less than or equal to alpha, we reject the null hypothesis. If the p-value is greater than the level of significance, we do not reject the null. And I, again, have a typo on my slide, and thank you for being patient with me. There's been a slight chaos here this week. Okay, let's try that again. So again, that p-value, we want it small. So if it's less than or equal to our alpha, we reject. It's greater than or equal to our alpha, we do not reject. Last step, and this should be step 4 for our method, again, another typo, this is the same as the traditional method. Nothing has changed here. So you're going to match up the decision that you made in step 4, reject or do not reject, with the claim that you labeled in step 1. It is very important that you are consistent. So if you made the incorrect decision in step 4, but you selected the correct box in this table based on your decision and your claim, I will give you more partial credit than if you got the answer right, but then we're not able to write the correct sentence to match it. So consistency is important. Show me that you're making connections between step 1, step 2, step 3, and step 4. Everything that you write needs to support that conclusion in step 4. Okay, so we've got one more intro video coming up that's going to discuss how we make a decision about which distribution to use. And then we're going to work through examples of each of the different types of hypothesis tests. If you have any questions about this week's material, let me know via email or drop by my office hours. Otherwise, I will see you in the next video.